Okay guys, so welcome to the next technological presentation. My name is Stojan and I'll be talking about the Cisco's Zero Trust architecture, what it comprises, how it works nowadays and so forth. Come on. Done. So, as a short intro, Zero Trust is not something new. So Zero Trust has been around since the 1990s. And basically, what it actually brings to the table nowadays is that it's not that we don't trust anyone, it's not that we don't trust our partners, our employees, our devices and so on, but it is that the perimeter that we're used to, so the firewalls, the outside appliances, the outside border that used to actually protect us is no longer enough. Shortly to say, we do need to establish internal protections which will actually govern what our users, our devices, our data does as it's connected to our networks, to our devices, to our environment. And as the attackers can actually quite easily penetrate our environment and exfiltrate the data, we do need to set up internal barriers to actually authenticate any communication actually happening on the network. We need to understand where the data is moving, who is touching it, who owns it, and so forth. And we need to understand basically what our users are doing, how they're connecting to the network, etc. And this is basically where the Zero Trust comes in. So basically, it, as I said, started in the early 2000s with deperimeterization, meaning that, as I mentioned, just the perimeter isn't good enough anymore. So basically just building the big wall without actually understanding what's happening inside our network is no longer good enough. So that's basically where the firewalls, where the data center security, where the endpoint security actually came in, so that we actually understand what and who and how they connect to our network. That we understand how the data flows, so basically who touches our data, who it belongs to, where it's being sent, and so forth. And nowadays, again, the Zero Trust architecture, which is the, let's say, current term, starting with Zero Trust Extended, and now the architecture, is basically something that a lot of companies, a lot of environments are actually moving towards. So, what's the basic idea of Zero Trust security and Zero Trust architecture? The idea is that we provide to the users, to the devices, to anyone connected to the network, the minimum allowed privilege, so the least privileged access, meaning that they get just enough access to the network, to the data, but not too much. And obviously only the authorized endpoints, only the authorized users can actually gain access to the data. And if they're no longer authorized, meaning that if their posture changes over time, if they change who they are, how they behave and so forth, we do need to revoke that access. That's the point, that basically we're talking about a continuous verification of the endpoints of the computers and users that connect to our environment. And as they connect, we basically need to check everything that we can about the endpoint. So we need to understand the full context. So be it from the device that's actually connecting, we need to understand it's, let's say, compliant iPad, which ran through BYOD. We need to understand that this is a Bob, which has been authenticated via multi-factor authentication or password, something like that. We need to understand that the data that they're actually accessing is a PDF, which is owned by our company, that they're actually allowed to access. And that as they transfer the data across the network, they're actually using secure protocols. So those are just parts of the metadata or the context that we need to understand as we control access to our network, and which we can then implement using Cisco's approach to the Zero Trust architecture. So obviously, establishing a solution like Zero Trust architecture is not like a single point of solution. We do need to understand how our workforce actually works on a daily basis. So how do they work with the data? How do they authenticate? Who they are actually? How do we establish the identity, and how do we know the identity has changed? We need to understand our workload. So we're talking about containers, we're talking about virtual machines, we're talking about data at rest, data at movement, and so forth. Again, understanding what happens with the data, who is accessing it, what are the workloads, what the processes are running, and so, etc. And obviously, at the workplace itself. So the workplace nowadays, it can be cyber cafe at an airport, it could be a fair like JITEX, it could be the HQ. So again, regardless of where the users connect and how they actually access data, we need to have a secure way of them to actually interact with our environment and for them to be able to utilize the data they're allowed to use. So, as any security story, you don't just set it up and forget it. So basically security has never been like that. So even in the old times, they used to rebuild the walls, they used to build the moats, they used to put the alligators into the water and so on. The idea is that it's a cyclical process. So we need to establish the trust. We need to actually understand which app is running, which user is accessing it, how they're connected to the network and so forth. We need to enforce the trust-based access. So we only allow access if that user, if that device is actually allowed to access it. If not, we need to stop that access, we need to obviously log it, we need to alert someone and so forth. And as I mentioned before, we do need to do this continuously. So it's no longer now that we just basically do it at the connection time, that we do it as the endpoint connects. We need to actually understand at all times that whoever connected the network, that basically the traffic that we're seeing, the connections that we're seeing are still valid, are still authenticated, are still the connections that we have authorized that we should have inside our network. This actually brings us to the solutions that we can implement the solution with. So for the workforce, for the basically people running around, for the authentication, for actually allowing access to the network, we have Duo, which is the Cisco's multi-factor authentication solution. For the workloads, so for your data center, for the containers, for the VMware and so forth, you have your filtration. And for the workplace, so basically what happens within your environment, within your company, within the networks that you control. Here's where we talk about DNA center combined with SD access, which actually allows us to establish this privileged access that we require. So let's take a closer look at all the building blocks that are actually here. So in addition, obviously, to the main building blocks, we said Duo, filtration, and SD access, there's a bunch of additional solutions. So if you guys just take a walk around the exhibition space here, you will see stuff from AMP to Cisco Trash Response to SD-WAN and so forth. So those are all complementary solutions that we can actually use to enhance our security posture, to actually help us better understand the security status of our environment, and to basically provide better security within our companies. Okay, so if we start with the workforce, as I mentioned before, Duo is the premium solution which integrates with Cisco AnyConnect, which actually allows us two things. First of all, it allows us the single sign-on authentication as we authenticate using the multi-factor access. So we identify the users either using their tablets, using their phones, using their computers, Macs, PCs, whichever. We ensure the devices are trustworthy, so we check if the phones are jailbroken, we check if they belong to the company, etc., etc. And basically we enforce the risk-based policies, meaning that we can actually assign different policies depending on who the users are and where they're connected. So basically it's not just, okay, you're user A, you have access to everything, but no. Basically if you're from IT, you might not have access to the HR database and vice versa. So that's basically important for us to understand who has access to what and how do we actually establish that. So using the Duo Access Gateway, which is a solution which actually allows us authentication from users who access, let's say, cloud-based resources, be it anything in Dropbox, on Slack, on WebEx, on Office 365, Google, and so forth. We can actually establish a way for the users to authenticate to our internal directory, be it AD, be it LDAP, be it Oracle, and so forth. But the idea is that as they authenticate, the solution, basically the authentication database, actually sitting in a secure environment. Obviously not the whole internet has access to it, but as our users, as our tenants try to connect to the cloud devices, we perform the multi-factor authentication, again using the either SMS, we can use the application on the phone, we can use different methods, and again still use the existing methods such as AD authentication to additionally enforce access to the environment. Okay, and this basically brings us to how can we actually do this. So basically, how do we protect against stolen and compromised credentials? Well, by using the multi-factor auth, by using biometrics or location awareness, we can actually limit who and how has access to a certain environment. To actually implement strong and continuous application resources, we use Duo Endpoint Health and group-based authentication. And to actually protect our users, we again can use Duo Health and additional services such as Umbrella and AMP to actually enhance our users' health posture as a connected network. If we have any workloads which are hosted within our environment, however, let's say in our DMZ, in our internal network and so forth, and we want to allow external users to gain access to those, we can use the Dual Network Gateway, which is an application that sits, let's say, within our DMZ. And again, as the external users connect to the internal resources, we can again use the multi-factor auth. We can use additional authentication methods to allow or disallow specific access to those resources. Okay, the next building block are the workloads. By the workloads, we mean the data center applications, the Kubernetes clusters, the virtualization infrastructure that's running within, let's say, our data center. Here, we can use the Cisco authentication to allow better visibility with automatic application discovery, with understanding which applications talk to which other apps, which protocols they're using, which ports are being utilized, again, who is accessing to which environment and so forth. We can provide micro-segmentation on per workload policies, meaning that for each application we can actually set up like a mini container, allowing them only access to specific resources for specific users, etc. And again, have access to this data in real time and understand the health of workflows. So we can let's understand if a certain app is not working, if someone has let's say, set up firewall rule that shouldn't be there, and so forth. So filtration using the environment agents, using the analysis of the flows within the data center will actually give us this data. Okay, we can obviously use visualization. We can actually set up the rules as we know them, and we can also set up dynamic policies, meaning that using security group tags, using Active Directory tagging, using different application discovery, we can in advance actually configure what types of access will be used for certain workloads. And then if we add an additional workload, which basically is the same type of what we had before, or basically the users authenticate the same way, we can utilize the same rules as we had before. So again, using Cisco authentication, we can actually discover and model any applications that actually happen within our environment. We can enforce the zero trust policies within our data center and for any users and applications that actually touch the data and the applications within DC. And we can basically limit workload access. Obviously, we only allow access to the users who are allowed to have access, and basically disallow or block any additional users that might actually have a problem. And we can basically provide the baselining. We can set up the zero trust segmentation and limit access, as you mentioned. Provide real-time monitoring, defend our workloads from attacks, and so on. And obviously do this in a dynamic way. Because basically at all times we understand which apps are running within our workload center, we understand which users are actually trying to communicate with them, and we understand basically what are the capabilities and what are the requirements for those apps and for those users that actually need to access this. And then again, using different tools as SD Access, Cisco Threat Center, next generation firewalls, and so forth, we can actually provide this visibility. We can provide insight into how the data flows are actually processed. Okay, and this actually brings us to the most well-known, or to the most classic way of actually providing segmentation, providing security. So to our internal networks, to our internal workplaces, where basically within our whole history, where we can actually use, for example, Cisco ISE to provide discovery and classification of devices. We can provide context-based access controls, again using security group tags, security group access to allow or disallow specific access, and provide continuous security monitoring, again by understanding the devices, understanding the posture of endpoints, and so forth. So, in order for us to actually implement networks which work on the zero trust architecture, we can utilize DNA Center, which actually provides an overlay networking for our environment, and actually provides a simple SDA fabric creation using VXLANs and additional methods, and easy setup of access control and security capabilities, anything from .1x to TrustSec to ISE integration, device sensors, profiling, and so forth. So again, using the DNA Center, we can actually implement a whole secure network with, by just using a few clicks. So as long as we have the software that actually supports it, so the DNA Center, we have the hardware which will enable us to actually provide the segmentation, the virtualization of the network, we can easily create differentiated environments within our company, set up the different VRFs or different networks where we can actually really enclose the different types of workloads, different types of traffic, and obviously also within the VRFs we can use the security group tags or the authenticated workflows to actually specify what types of access is allowed between the different types of users within those VRFs. And again, by using the SDA for the wired or wireless internal networks, we can then basically use anything from SD access, Cisco ICE, AAA profiling, and so forth that have been around for a while. We can utilize the threat-centric NAC and ADM to actually understand who connects to the network, what is the posture of their endpoints, and so forth. And we can use network analytics and group-based policies to actually extend the security from our internal network to the cloud, to the extended workspace where our users exist as well. So in summary, as you mentioned, we will use Duo to actually authenticate our workforce, be it on the iPads, be it on the phones, be it on the computers. We can use saturation to actually utilize analytics and security for our workloads, and use SD access to provide secure segmentation and visibility into our workloads. Thank you very much.